Right, now let's move on to something a little bit more interesting. This would be an example of two classes that make use of casting. So the cast here is being used in my main method. I have this B class extend my A class. So in other words, B is the child class of A. And we are going to have one first example of casting. So already mentioned about casting, right? Casting is just this idea that you want to treat that given object as a specific type, right? So for instance, you might have, actually, let's go with that example. You have a parent object A. So I declare that variable obj with the type of the parent A. But then I go and call the constructor of the child. So in Java, this is always possible and allowed, and there's nothing wrong with that. And we typically refer to that as an implicit upcasting, right? Implicit because I'm not even using the casting operator here, the parenthesis. Okay? So that's what we would call implicit casting, right? So for instance, I could come here and be a little bit more explicit, and that would just result in the same, precisely the same result. But I don't have to do that, okay? So I can just suppress that, and that would just have precisely the same outcome. Why upcasting? So upcasting refers to the idea that I am casting to the type of the upper class, the superclass, right? So it's kind of implicit that you have the superclasses on top of the subclasses or the child classes. So in that case, if I would draw an inheritance tree, I would draw it like this, right? So if I upcast from B, I'm casting as A, right? So similarly, I can also think of the opposite idea. So I can actually also think of casting downwards, right? But then that would mean that I would go from an object type as a parent type and cast it as a child type. Generally speaking, in Java, you cannot do that, right? Why? Why is it that I cannot generally, right? Generally do that. Even more like high level. Can I say, for instance, that a child instance is a parent instance? Can I say that? Can I say that an instance of that class is a class? You can't. Can I do the other way? Can I say that an instance of A is a B class? Nope, cannot. Right? And that's one way to give the answer to what I asked, right? So if you cannot, then how would you actually cast downwards? Right? Because that would mean that you are going from a more general type to a more specific type, right? So for instance, if you have a member declared here, right, that member does not magically appear in an instance of a parent class. So generally speaking, you cannot downcast. But of course, there are always exceptions, yeah? And let's try to see one such exception. So this is an example of upcasting. Everybody got the idea? Yeah. So they don't do the same thing. They're different things, right? Inheritance is how you make sense of the members and the relationship among the classes. So this is more like type checking. So that's the thing. But typecasting is to make the type compatible, right? That's why you cast in the first place, right? Inheritance. So the way that you relate these two things is by making use of the is-a relationship, right? Is how you relate the idea of type checking with your inheritance tree, or some other things like interfaces and so on, right? But they are like different things that somehow are linked together. Okay. Okay, so work off? Nope. Yeah, so this is an example of upcasting, and we can show this example here of downcasting. So let's see. I might need to. So this here is doing nothing, right? So this here is just creating an object type with the child class, and then oh, actually, this is also downcasting. Sorry. If I would want to create a new variable, which is what I am doing here with the child type, right? And then just use this variable name here. So this variable name is typed with the parent class. Okay. So again, generally speaking, that will not be possible, right? Because that means that I'm trying to go from one child type, right? From the parent type to the child. And that's not what we typically can do, right? However, in this case, I just came from an upcasting, which means that the way that I built the object in the first place was using the child constructor. Okay, so the way that I built this object that is being referenced by obj is by calling the child constructor. Because of that, I can go and do the other way around. So I can go and cast it back to its original type, which was the child type. So that would be one example of downcasting. Hard to tell. Cannot think of a. I mean, typically you would first avoid doing downcasting, right? Because you just incur that possible. Most places will not even be able to compile. Second, it's really confusing. So when you create code, of course, you want to be providing an implementation that is as simple as possible, but achieves your goals, right? So there's no reason to like complicate things if you don't really have a strong reason to go with that, right? So I cannot really think of an example where that would be justified. But that's still like an interesting thought exercise here. Just makes sense. Just to understand the in a way the limits of the syntax of the language, right? So in that particular case, that would be an exception of that general rule that I just mentioned, that you cannot downcast, right? The exception is if you have previously upcasted, so then yeah, you can actually go and downcast. So that'll be the exception to my general rule. Make sense? So that's about it. That's casting. Now let's observe the execution of this program. But even before that, I'll just comment this one. Let's take a look at the implementation itself, right? So my child class has one field, one constructor, So the constructor is just printing something. A B method that is implemented that prints also a message here, B exclusive. Then I have a method one that is another method that prints B. And then finally, I have main, which we just saw, right? So for now, let's just stick to this first line here, which is really just calling the constructor of the child and then storing that newly created object using the parent type variable. Okay. So let's just stick to that one line here, and then I'll go back and talk about the remaining lines. But I want to go and show you the parent. So the parent is called A. I have another value here that is set to 1. By the way, do we have value here? Yeah, so we have a hidden value here, right? So same name. So we have a constructor that calls method 1. And then we have a method 1 that prints A, right? So if I would predict what would happen if I run this program, how would I go about it? So let me give you one way that I would try to do that, yeah? So I would come here to main method. I would see the statements. I only have one statement that is not commented. So here I'm just creating an instance calling the constructor of the child. That's the class that I have open here. So my constructor of my class here only prints asterisk. So then what I would expect to see as an output in this program is really just asterisk, and that's it, right? Right? Anybody doesn't agree? What about the parent constructor? Oh, I don't have super here. So I'm not going to call the parent constructor, right? Wrong. So if you don't have super in a child constructor, the program will still call the parent constructor. No, I'm just analyzing what happens, right? Just trying to predict what's going to happen.
Right, but if it's still false, why would you call that?
No, I mean it's a standard. It's a convention that the Java language went with. Even if I don't have an explicit call here, I would still have that. So one thing that I could do, of course, just come here and have that, and that would be equivalent. That'd just be the same thing.
Why would you call the parent constructor unless you had duplicate fields?
It's not. It's more like I actually don't have a choice, right?
Right, but I mean, why would you call it out, like type it out, if you didn't need to type? So like for the calling the super constructor of A2, unless there's a field that is duplicated, like the lives field.
Maybe tell me if it is the same thing that you are asking. So I could have a constructor in my parent class that is just empty and doesn't do anything, and that's fine. I can also not have a constructor in my parent class, and that's also fine. Is that what you're asking?
I was just wondering why you would call it out in the child class, if it automatically.
Oh, you don't have to bother. You typically don't have to bother. I personally like to be as explicit as possible. So I would actually go here and put super, just make it easier. To just remember people that actually that's going to happen anyways, even if I remove it. Yeah, okay. So then let's now that we know that the parent constructor is going to be called, let's actually take a look at the constructor here, right? So we did see that, yeah. So this is just calling another method, and that method just printing A, right? Yeah. The implicit call is always on the default constructor. That's a very interesting question. The implicit, which is what we have here, is always on the default one. If I declare a custom constructor, then suddenly this program no longer compiles. Because if I declare a custom constructor, Java will not create a default one for me. So that means I don't have a default one, right? So I do need to have at least one constructor, but if I don't provide any, the JVM is going to understand that we do need to have at least one kind of constructor anyways. That's just going to be more like a placeholder. It's going to be just having that default constructor with no implementation in it, right? It just provides that. It doesn't really do anything because there's no code running in that constructor, but there will be a constructor there just to make things compatible, right? Because when you create an instance of a class that inherits from another class and so on, if any of those classes on the way up to object do not have a constructor, so then this breaks my Java environment. So that's why you do need to have on every class on your path upwards to object a constructor. Even if it is just a default constructor that was automatically created by the Java compiler for you without any statement, any implementation, you still have that constructor just to make things work. All right. So that's why if you don't have anything, then the environment is going to create one for you. If you go and declare one that is default, then the implicit call here still works. If you go and declare one that is non-default, now things break again. Because now the only constructor that I have in my parent class is going to be a non-default. So then the implicit call that is going to be done on the default one is just going to call something that do not exist. Make sense? So let's try to predict the outcome of we already ran out of time, but actually, let's just move that to the next, because there's a lot of things that I want to discuss. So just in terms of curiosity, right? So what I would expect would be to see A followed by asterisk, right? And if you actually go and run, look what will happen. What's going to happen? So maybe let's try to go with the sequence of things that would happen in that sense. So we only have one uncommented line here. So I have a variable that is typed with the parent class, but I call the constructor of the child class, which means that the constructor of the child class is going to be the one that is going to be invoked, right? But when we get there, that's the constructor that we are considering. I mentioned that when you don't have a super call to the parent constructor, even so, the Java environment is going to do that for you, right? So even if you don't have an explicit statement there calling the constructor of the parent class, this is still something that's going to happen, which means that in a way the sequence of constructors would be from a perspective of actual execution is going to be from object class constructor all the way to the subclasses, all the way to the current class that you are at. So in this case here, that's going to be object and A then B, right? Because you have A not inheriting from any class. At least we don't declare that, which means that it inherits from object. So that means that we need to take a look at the constructor of the A class, right? Let's do that. That's our constructor here. And here we have a call to that method one, right? We do have that method one here, right? That just prints out A. And if we go back here to B, you will see that this is just going to have the asterisk, but there's also an override of that method here, right? That prints B. So then perhaps you would be caught by surprise if you run and see that the output's going to be B. Where's B star, which means that somehow my child, where is it here? My child method B was the one called, right? Why? Anybody can tell me?
Because the parent class calls method one, but it's calling it from the child class, so it calls the child class method.
Yes, so it's calling the method on the object, on the instance, right? The object was created using the child constructor. So do you remember that I probably mentioned more than one time, that when you create an object using some kind of constructor, the method that is called is the overridden method that's determined by the constructor. So because my constructor is the child constructor, so then the method that's actually going to be called would be the one that was overridden by the child. Right? So I usually do a drawing that I'm going to try to do right now to relate that to what I typically call the memory model. So imagine that you have a portion of your memory dedicated to store objects. Then I'm just put that up. So we only created one object, at least so far. We have the tree here, where my parent is called class A. And I hope this is readable. Not see, but I hope it is. Let me know if it is not. Is anybody connected? Like not. All right. So when I call the constructor, I call the constructor on that guy, right? On the child parent, child class, right? So imagine that when you create that instance of an object in memory, what actually happens is that it's going to be some part that is more related to the class, right? So call it static. And there's some class that is related to the parent. We can just suppress object class here, but we want to somehow represent this idea that I'm going to have members that are declared at A or from A, and I have members that are from B, right? So all that, right, somehow is going to be referenced by any instance that I create of that B type, right? So then you have the variables. So the variables, this thing is not helping much. Let's see. The variable, let's call variable one, is going to be doing this in essence just a referencing, right? So because this is a reference type, so I'm going to just be referencing this portion here. But then my variable has a type, right? So maybe my variable type is the child type. It is also possible to have another variable that I'm going to call var2. And I can type that as a parent class type, right? And I can still reference the same location, pretty much, right? Why am I drawing that? Because in terms of method calls, right? If you have a method that is implemented by a child and you have called the constructor, as you have in this example here, using the child, then as I just said, we already know that the overridden method is going to be the one that is going to be called. Okay? Yeah.
So if we want to call the method one of the A class, the parent class, at that time, should we use super dot method name or this dot method?
Super would not actually work in that case. So in that, I mean, ideally you would want to actually use the constructor of that class to be able to call the override of that class, which would not in any way relate to that override. Right. So in that case, the super will not gonna save us.
So in this case, we can't call the method one of the parent class.
From the child, you could, right? But then if you have a type of the parent, then that doesn't really make a lot of sense. That I guess it just creates confusion. Right? From the child, you could use super to call the parent method. from the parent itself, you could not, right? I mean, there's definitely one sort of not best practice to follow with this example. This is really just for us to understand what's going on, right? Because this kind of obfuscates the understanding of the logic of the program, which is always not a good idea, right?
And
So in other words, if you want to be clear, and you also maybe you don't even need to override. So it's if you really need to have access to a method, right? Not going to benefit from going with the same signature, then just choose a different signature. As simple as that, right? And you can still, of course, call the method, right? You can still reuse the code just by invoking the method. So in other words, most likely it was not really a good idea to override the method here in that child class from a software engineering perspective, okay? But here just trying to see our understanding of the code, the flow of the code and what the code actually is doing.
so if we try to just to B2 object equals to new B2, still the output would be the same, right? Or will it differ?
Say it again? If
we didn't cast to A2,
yeah, the method would still be the same, yeah.
the output would be the same.
Yes, still the same, yeah. Right. Again, because of the use of the constructor. It's always about the use of the constructor when it comes to make sense of the methods. Okay, you just observe the constructor, that's it. With the fields, oh, sorry, yeah.
I mean, like, it is all about the constructor, so normal methods also work in the same way. I mean, like,
No, that's what I was gonna say. With fields, it's a different story, right? So with methods, yes, that's how we make sense of that. With fields, the type of the variable is going to determine how you access that given variable. So the field is a variable, right? So that's the same as thinking that when you say, let's say, var2 dot field name, and maybe I could put an F1 here to represent a field, and then another F1 here to represent another field with the same name, so which means that this field here is hiding that field, right? So if I want to access this guy here, I can use var1 because the type matches the type that I have here. So var1 dot f1 is going to access this guy here, right? var1 dot f1, and then var2 dot f1 is going to access that other guy here. Okay. So these, and it doesn't matter which constructor I use in that case. Right, so I'm no longer making sense of that in terms of which constructor was called, so on. So I'm really just looking at the type of the variable. That's how I am going to tell which variable I'm actually accessing. Okay. Yeah.
so for variable two, are we not typecasting it? I mean, like, is it like every object?
It's
every object?
so I can, if you just want to declare the variable and reuse the same reference, you can cast, you don't have to cast because it's going to be the parent type, right? But there's an implicit cast to A because of the variable type, right? So actually we have an example of that here, right? Oh, not the first one, sorry, right? This is the parent. This is the child, right? Then I can go ahead and create a second variable with the type of the child if I want, right? Or directly just match the type of the variable to the constructor, which would be like the more obvious case. I just write like B2 something equals new B2. Just direct type match. So no casting needed. Make sense? Did I answer your question?
So basically, I mean, like, for the first object that we have created in OBJ,
Mhm.
So, I mean, like, if we want to, get the field of A2, I mean, like, if both of the fields in, parent class and the child class are the same.
Mhm.
But we want to access the field of A2, I mean, like, do we need to do?
The
something
parent.
specific?
You need to have a variable with that type to do that.
Now we are having the variable of that particular type, right, A2?
And you need that, right? That's what I'm saying. Like you need to declare a variable with that type. All right. Or I mean, you can like, you actually can just cast it, right? And then do dot, you can use the parenthesis and then do dot, that would also work. So you don't even like assign that to a variable, right? But more clearly, you want to have a variable. So you declare a new variable, same way that we did here and here, right? So you declare a new variable, and then with the variable, you can do dot field name. Make sense? Any more questions? Am I sharing my camera? I hope I am. Yeah, because Zoom sometimes, yeah, okay.
I think you stopped sharing.
Yeah, no, I just wanted to check if that would be visible from the recording. Yeah. Oh, good, makes sense? All right, so you can just yeah, go over this code one last time, right? So here, after I do that, I can these are just added, right? So I can get rid of that. I can just do the opposite and downcast. I also mentioned last time that you typically cannot downcast, right? This is an exception. Why? Because you have just upcasted. So then that means that you have already used the constructor of the child. So then it is legitimate to go and type a variable with the child type, which is what you are doing here, right? So these would be okay. In that case, because the previous statement was an upcasting, right? Or some previous statement, right? So you can only downcast if you have upcasted before. Here we are just calling that method. As I mentioned, when you override the method, that's always the overridden one, right? We already saw that. This is just another example of downcasting. And this is the example that I have just shown you, right? With the two variables where one is typed as A and one is typed as B, right? So object 2 here follows the type of the child. Maybe I should just go with the same name here, right? So obj 2 is the child, right? So it's the other way around. Okay. Parent, child. Okay. Make sense? So I would probably study that example for the exam.